Hi, my name is Gagan and I am from RPS Public School Dharwada. I have made a project that can help visually impaired people in their day-to-day life. This works on the principle of an ultrasonic sensor. This is an ultrasonic sensor. It has two parts, a transmitter and a receiver. The transmitter sends out a burst of sound that reflects off the surface in front of it, and the receiver receives those sound waves that are reflected off of a surface. When this receiver receives a signal, it sends it to the microcontroller that I personally designed to it. The microcontroller turns the analog signal into the digital signal that can be read by the output device. The output devices are vibration motor and a buzzer. The thing you can see here is a vibration motor, and just to the side of it is a buzzer. If an object is in front of it, let's just say 110 centimeter, it will alert the user by using the buzzer. And if the object gets closer than 50 centimeter, it will then begin to vibrate to let know the user that the object is dangerously close to him. I will now show you the working demonstration of this project. I'm gonna turn it on, and I am going to keep it vertical so that you can see it vibrate and buzz. So I'm gonna turn it on right now. So it's on. Now if I put my hand, it begins to vibrate and buzz. See. You could see that it begin to vibrate. Uh, when an object gets closer than 50 centimeter, it activates the buzzer and vibrator simultaneously. The vibrator vibrates the whole chassis that I made by myself. This chassis is inspired by a VR headset and it is really comfortable to wear. I have added a battery to it that can power it for 80 hours constantly. I also added a charging port to it so that it can be charged and used regularly. The microcontroller you see here was custom designed by me, and the PCB it is sitting on was custom etched and designed by me. This consists of an Atmega 8A microcontroller and transistor and some resistors. The thing you see here is a crystal oscillator and it handles all the distance and time related calculations. I made this as much user friendly as possible. I want to give the user a real life experience like a normal person will experience in their life. This mimics the human field of view. The human field of view consists of 180 to 192 degrees field of view. The human eye can focus onto an object up to infinity, and it can clearly see any object that is around 10 or 20 meters in front of it. This can mimic the human field of view as it has 160 degrees of view, and it can focus up to an object on 16 meters. I want to take this project further and get some funding so I can hire machine learning and AI engineers to develop my project further. I'm now gonna show you some demonstration that mimics the real life situation that can happen to a blind person. These were some examples that could happen indoors, but now it's time for showing you some examples that can happen outdoors.
चलता रहे
As you saw, that this project really works. My future goals are set really high, and I want to add many features such as GPS and facial recognition so that the person wearing this can feel like a normal person and not be discriminated against. I hope you enjoyed this experience and fully understood the concept that I was trying to explain. Thank you and have a nice day.